This is page 406. We got this one more video, and we're done with activity 1, where we talk about the properties of quadrilaterals, and we'll get into something new. Thank you for sticking around and watching this sequence of videos. As we talk about their properties, it is important to understand why these properties are set up the way they are and how you can use that information to solve problems. All rectangles, or a rectangle is a parallelogram with all angles congruent. But is this true? How do we prove it? Well, here's a rectangle. Consider it ABCD. And then if you think about how it's a quadrilateral as its overall description, the interior angles of a quadrilateral, we're going to keep talking through the bell, sum to 360. And in a rectangle, by definition, look at page 420 for the definition of a rectangle, all of the angles are congruent. So 360 divided by 4. 90 degrees. All these angles are 90s. 90 all the way around. There, and of course itself. Now, what do these angle measures tell you about the relationships between adjacent sides? I mean, honestly, if the sides come together and form a 90 degree and a 90 degree, and all the sides must be perpendicular. Adjacent sides, adjacent means next to. Adjacent sides are perpendicular. Two more here, let's go. So as we keep walking through the next one up, what theorem can you use to prove that opposite sides in a rectangle are actually parallel, which is enough to justify that the rectangle is a parallelogram and not just a four-sided shape with four congruent angles? Well, here's what we get to say. We get to use the same side interior angles Converse theorem. Yeah, you weren't expecting that, were you? But honestly, that says that if you have same side interior angles like angle BAD plus angle ADC, together they are 90 plus 90, which is 180. And that's same for angle ADC and DBC and blah, 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 blah. And so all of these angles add up to 180 when you place them next to each other because 90 plus 90 is 180. So therefore, opposite sides are parallel. Opposite sides are parallel, and that is enough to say that a rectangle is actually a parallelogram. Last of all, since a rectangle is actually a parallelogram, what are the things that hold true? Opposite sides and angles are congruent, and the diagonals bisect each other. Of course, that video might be the fastest one yet, which is good news for you. Please feel free to pause, rewind, rewatch in order to see the parts that you're missing. I am particularly proud of the logic that happened for part C. So give that a thought process. Where did LeBranc come up with that, and what was he thinking about that along the way? And let's use that for, our future learning. Thank you for watching this video. See you on page 407.